So, hello and welcome to another video from sickmouse.co.uk, where you can find lots of free GCSE and A-level maths videos. This one's about binomial expansion for module C4. Of course, you've learnt this also in module C2 of A-level, in Excel of course. But although you're possibly taught two methods, including this method here, okay, for C4 you just have to use this method because we're doing some funky stuff with n. Instead of, when you were expanding in C2, it kind of made sense. You kind of square the bracket or did it to the power 4, okay? But over here, we're not going to use normal kind of numbers. We're going to use fractions and negative numbers, which is really strange. How do you expand a bracket to the power negative number or whatever? Okay, so when you do funky stuff like that, you're kind of constrained to about how you can actually expand it. Okay, and it also constrains what kind of numbers you can have. So not really actually. You do have to say what the expansion is valid for. So once I've got crazy numbers that are not just normal whole numbers, i.e. negative numbers or numbers less than 1 or fractions, okay, automatically this AX bit, okay, is less than 1. The modulus of it is less than 1. Now you might think, if you've seen the binomial expansion, this method before in the, what's it called, formula book, that it looks a bit different. Well, because they write it up the messed up way, okay? So I usually write it in a way that makes sense, and they usually write it in a way that makes it really difficult to understand, okay? They don't even write the A bit, they just write X there, okay? And basically it doesn't make sense. They ignore what they've got to say. Understand this, and then you really understand what they've got in the formula book. The formula book is just a complicated way of writing it. Anyway, let's get on with doing an actual question. This is the core thing. That's all we're really practicing, and a few tiny things on top, and all this stuff is quite straightforward, boring really. So let's go for it. Here's number 1. If I've got 2 root 1 minus 3x, that can be converted, so it looks a bit like this with a power, okay, because square root turns into power half. So now I've got 2 brackets 1 minus 3x to the half. Okay, and I'm happy to start using this now, because as long as I've got a 1 in the front, this method works. So how does it expand? Let's give you an example. N, of course, is your power, n, and don't forget that you start from n and it goes to n minus 1, then it goes up to n minus 2, and this goes from x to ax to ax squared, ax cubed, 2 factorial, 3 factorial. There's an obvious pattern, right? So let's start applying the method. I've got my n on the top, so my n is half in this case, so it starts with 1, as this one does, so I've got 1 there, and then I have to do nax, which means half times ax. Ax in this case is minus 3x, so half times minus 3x. So that's basically my second term. My first term is there. My third term is basically from this one here, so n times n minus 1, okay, which is half times minus half, because if n is half, then n minus 1, half minus 1 is minus half, so that's that bit there. Then I have to do ax squared, which is minus 3x squared, over 2 factorial, which is really actually just 2. Okay, if you don't know what factorial means, I'm shocked. Okay, how can you get up to C4 without knowing that? Because in C2 you would have known factorial means, for example, 3 factorial means 3 times 2 times 1, or 5 factorial means 5 times 4 times 3 times 2 times 1. So 2 factorial is 2 times 1, which is just 2 really, as I was saying before. Anyway, let's do this part of the expansion. N, then n minus 1, n minus 2. So if n is half, then n minus 1 must be minus half. Take away 1 again, gives you minus 3 over 2. Of course, now we've got ax cubed over 3 factorial, as that says. Right, and What else? Oh yeah, the point is that this expansion goes on and on and on. It doesn't stop at ax cubed, but typically we just stop at ax cubed, and I'll explain why soon. And of course, it said 2 times all of this. So this stuff is equal to this, roughly speaking. Of course you can expand it more, but I'll tell you as I just said. So normally they just ask for the expansion up to x cubed, and then you have to do 2 times all of that stuff. So let me go through that with you a little bit, although I don't really want to tell you how to multiply brackets at this stage. Should be very easy for you. So that bit says 1, so 2 times 1 is 2. So that's the first bit of multiplying the brackets. And this stuff is multiplies to minus 3x over 2. If you times that by 2, it becomes just minus 3x. And on and on and on. Very easy stuff. Okay. Let's go to example number 2. I've got 5 over root 9 plus 2x, which easily becomes this. Yeah, because root means half, power half, and the minus means it was underneath because minus means flip upside down or divide by. So basically this is equal to this. Okay, now what's the problem with this, or what's the difference between this example and that example in terms of what's so special about it is that it does not have a 1. And I said as before, I said you need to have a 1 to use this expansion, because look, it says 1 plus something, but this says 9 plus something. Yeah, with an x in, of course. So all I do is I take this bit here and I write it here, and I say, well, you know, 9 plus 2x, I can write it as, I can divide it all by 9, so I get 1 plus 2x over 9, and then put a 9 outside. So basically, that's the quick way of doing it. Divide it all by that number and take that number outside. Very simple. So now this to the power minus half is this to the power minus half, and 9 to the power minus half is basically 1/3. Okay, because 9 to the half is 3, minus means turn upside down, so 1 over 3. So basically that 3, that becomes a 3, and I still have to do that to the power minus half. So basically I get 5/3, because that 1/3 times the 5 becomes 5/3, and that to the minus half, well, I can't be bothered to expand that. You know what? I forgot something. I forgot to say what this expansion is valid for, which is very interesting. Well, it's not that interesting, to be honest. I exaggerate, don't I? So this is valid for minus, well, my ax, as it says, where does it say it? Ax has to be less than 1. That's what we're looking for. So my ax is minus 3x, and the modulus of minus 3x is the same as modulus of 3x, of course, because modulus means basically get rid of the sign. It means what's the physical size of it. So if 3x is less than 1, therefore x is less than 1/3, and that's done. So it's valid for that. Sometimes they ask for that, or sometimes they just tell you anyway. Okay, now another example. Now from here on it's just so easy. It's just very tiny examples I'm explaining. If you got something like this, you got 2 factors on the bottom, it makes sense to break it down into partial fractions. If you don't know what a partial fraction is, just go and watch the partial fractions video, which is also part of C4. Okay, so once you're breaking it down like that, obviously 2 over 1 minus 2x is the same as 2 times 1 minus 2x to the minus 1, and that's obviously just 1 plus x to the minus 1. Okay, so very, very simple. And but the interesting thing about this actually is this bit. What is it valid for? Well, you got 2 expansions going on, so it's valid for, this bit is valid for minus 2x is less than 1, as it says here, the modulus of that, of course, and the modulus of x. For this expansion, this expansion is valid for x is less than 1. Okay, but we need one thing, one expression that is valid for the whole thing. Yeah, not just this one or that one, because this is a combined question. Okay, because we're thinking about, this is what it came from, one question, not 2 questions. Okay, so we want an inequality that is true in both cases. And which one is true in both cases? Well, that basically means 2x is less than 1, therefore x is less than half. So if x is less than half, it is also less than 1, so that means we use this inequality because it's true for this situation and this situation, i.e. for both expansions. This is true. Okay, now more easy stuff. I kind of mentioned this earlier on. Why do we normally stop at x cubed in our expansions? Because if x is a really small number, so for example 0.00005, okay, then x cubed is going to be really small, so small that we say it is negligible. You can ignore it basically, okay? So that's the idea of that, and that squiggly equal sign means roughly equal to, yeah? So that expands to this. But it was roughly equal to this, yeah? Okay, although I did say that this is equal to this and I stopped at x cubed, it's equal to that up to x cubed, yeah? But, okay, you get what I'm saying. So basically what I'm saying is, as this is what you would write as x to the power n for n is greater than 3 is negligible. Okay, sometimes it's when n is, you're allowed to go up to power 4, okay? X to the power 4. Okay, depends on the number. It depends what you think is negligible or the questioner thinks is negligible. Okay, so this is the kind of stuff you can write down. If x is small, blah 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 is negligible. Anyway, let's get on with this and try to finish it off really quickly. This again, this is comparing coefficients. That's all it really is, okay? I expand this, I've got an a there, not a number, so I expand it with the a inside it. You should be practiced with this already from C2, and so they're saying the coefficient when expanded it has coefficient 12 for x squared. Okay, so the coefficient of x squared is 12. Okay, so this bit is 3a squared x squared, and we're told that should be the same as 12x squared, therefore 3a squared is equal to 12, therefore a squared is equal to 4, and therefore a equals 2, and that's it really. And finally we've got 1 plus 3x squared to the power minus 1. What's special about this? Oh yeah, right. There's a common phrase when you come to this topic, which is write out the non-zero terms. Okay, when you expand this, okay, you don't get any x's, do you? Can you see? It goes straight to x squared when you expand it using this expansion, and it goes to x to the power 4 as well. It doesn't do any x cubed. Okay, so these are the zero terms, obviously, because you got 0x's and 0x cubed. Okay, so what they say often is write out the expansion of the non-zero terms. Basically, don't waste our time by writing this stuff, because we don't want it. What use is that? So these are the non-zero terms here. 1 minus 3x squared and plus 9x to the 4.